Hey, Bryson. How are you?
I'm fine. How are you?
Good. Um, I had some students from my class ask some questions, so I am going to cover those. And it's actually from the textbook, but I do have Miss Wynn's worksheet loaded also. So, do you have something specific that you wanted me to cover from that?
Yeah, from the worksheet. Yeah, just a
Okay.
couple problems.
Okay.
Mhm.
Let
Yeah,
me let me get to that.
yeah.
This is the worksheet,
Mm-hmm.
correct? Okay,
Yes.
good. All right, cool. All right. Which one? Or you
I
want
would
me to do
say
one from each section?
there is, well, yeah, probably one from each section would be fine.
Okay. All right. Do you have a particular one in the first section that you want me to do, or you just don't care?
Not in the first section. In the second and third sections, yes, but not in the first.
Okay. All right. So the first section, what you want to do is your the constants, the 4 and the 2, you basically are just going to multiply those like you would any other multiplication problem. But with the rules of exponents, you want to add the exponents. And in this case, they're rational expressions or fractions, a student's worst nightmare. So you have to get a common denominator. In that hope that all of that was eventually going to go away, it rears its ugly head, right?
Yeah.
So you got your 4 times 2, which that's going to be 8. Um, and then you've got x raised to the 4/3 times x raised to the 3/4. So you're going to get a common denominator, or for 3 and 4, the common denominator would actually be 12 for each of these.
Mm-hmm.
And 3 goes into 12 4 times, and 4 times 4 is 16. So this 4/3 becomes 16/12. And 4 goes into 12 3 times, and 3 times 3 is 9. So this 3/4 becomes 9/12. And once again, that 4/3 becomes 16/12. And now that our denominator is common, we just add our numerators. So 16 plus 9 is 25 over 12. And that can be reduced to basically that's 25 over 12. That can be reduced to, well, you probably want to leave it as an improper fraction because it's basically you've got x squared and then x to the 1/12. So you're just better off leaving it like that, really,
Okay.
instead of having two variables. So your final answer is 8x 25/12.
Okay.
Okay. And actually, number 2, pleasant surprise, the 1/3, and the 2/3 for that one. It had the denominator. You don't have to get a common denominator. So, did all of that make sense to you?
Yes, thank you.
No, no problem. And numbers 3 and 4 are going to be a little more complicated because you'd have to get a common denominator for both the x and the y variables on those two. All right. So for which one for the second section, 5 through 7? Which one?
Number 7.
Number 7. Oh yeah, that's a humdinger, isn't it?
Yeah.
Just want to break this one down little by little. So what you're going to do at the top, your exponent rules say when a power is raised to a power, you're going to multiply. So my numerator then becomes x, and then 5/3 times 1/2 is going to be 5/6. So now my numerator is a little more simplified, looks a little more user-friendly. The denominator is x to the 7/4, and then you've got x times x to the 4th. So what I want to do here, Bryson, is I want to get a common denominator with this 7 over 4. So so 4 goes into 4 times, and 4 times 4 is 16. So that 16/4 is the same as x to the 4th. So now we have x to the 5/6 in the numerator. And at the bottom here, we're going to add 7 plus 16, which is 23. So at the bottom, we have 23 over 4.
Okay.
Okay. And now what we have to do is get a common denominator at the top and the bottom, which what would be common there is going to be 12, because both 6 and 4 go into 12. And so 6 goes into 12 2 times, and 2 times 5 is 10. So my x to the 5/6 then becomes x to the 10/12. And down here, 4 goes into 12 3 times, and 3 times 23 is 69. So now what I'm going to do is subtract 10 from 69, because the quotient rule tells me I'm going to do subtraction, which that gives me a negative 59. So that tells me I'm going to have x, so it's going to be in the denominator. So I have x to the 59th over 12.
Okay.
That's quite an answer, isn't it? That's ugly.
Mm-hmm.
Woo, that is ugly. And technically, I'm just going to say technically you would need to rationalize that denominator, because believe it or not, if I change that to a rational expression, it actually looks like this. And you can't have a rational in the denominator, but Miss Wynn told me that y'all aren't doing that just yet. So she is happy with this answer right here. Okay?
Okay.
But I just wanted to kind of set you up to expect that in the future.
Okay. Thank you.
Yeah, no problem. I don't want to disappoint you, but I figure it's better to break the bad news to you up front.
Yeah.
Has anybody else joined Math Lab yet, by chance?
I'm not sure. I don't think anyone has.
Okay. Oh, it's just me and you hanging out.
Mm-hmm.
Okay. All right. So the next section. Is there a particular one that you wanted me to do?
Well, on the next page, there's actually 2, I guess.
On the next page, so you're good from 8 through 14?
Yes.
Okay, cool. Good job. That's awesome. All right. Which?
Let's say like 18 and 19.
18 and 19. Oh, they look fun. Okay. What you need to do on these is break them down into their factors first, because it would be easier to work with factors of 570 and 75 than. So basically you're going to have this. This is how I would do it anyway. And I think Miss Wynn does a lot of factoring too, if I'm not mistaken. Because you want to look for sets of 5. think I factored that right. So 500 breaks down to be 2 times 2. Got that. I got that. Times 5 times 5 times 5. So I've got those. And then 75 breaks down to be 3 times 5 times 5. Does that make sense to you?
Yes.
Okay, so that's 500. And this is 75. And I don't have my X's in there quite yet. But what you want to do is pull out sets of 5. So you've got this. There's only one set of 5. So you've got -2 times 5. And then everything else that's left underneath there. That's 2 times 2 times 3. And then we've got x to the 7th underneath there. And so 5 goes into 7 one time, so I can pull one of those x's out. And there would be 2 left. So 2 times 2 is 4 times 3 is 12 with 2 of the x's left. Is this making sense?
Yes.
Or not really?
At first it wasn't, but then I see where you were going with that. So yeah, I get it now.
Okay. I don't know. She may do it slightly different, so I'm really sorry. But I usually, what I try to do is take this number and this number, my constants, if you will, and I break those down to see what I can get out, and then I work with my variable. And I didn't really have room to write my variable. He didn't go anywhere, but he was up here. I just ran out of room. I should have started further to the left. But I took, this was x to the 1, and then you just add those. 1 and 6 becomes x to the 7th. And then I broke everything down into factors.
Okay.
And if it can't, you bringing sets of 5 things out. Like if it's a square root, I think she says that people are going on dates and you get sets of 2. And then if it's cubes, you're looking for sets of 3. And if it's a 4th root, you're looking for sets of 4. And this time we were working with a 5th root, so we were looking for sets of 5. And once it comes out of that 5th root, whatever that numeric value was, in this case it was 5, whatever that numeric value, that's what came out.
Okay.
Does that make sense?
Yeah. Mm-hmm.
Okay. All right. So your final answer is this -10x times the 5th root of 12x squared. That's quite an answer, isn't it?
Yeah.
So it's like, wow. How are you with like 17, where they're adding and subtracting and you have to factor those out because you can only combine like radicals? Are you feeling good about those?
Yeah. Mm-hmm.
Okay, cool. Good job. Sometimes those can be even trickier. Okay, is there another one on this page?
Yeah, number 19.
Oh, number 19. I forgot you said that. I'm sorry.
It's fine.
All right, so once again, I'm going to do my factoring. I'm going to do that up here. 192. 96. $48. Okay. So I've got the fourth root, and I've got 1, 2, 3, 4, 5, 6 twos from the 192. Do you see where I get those? 1,
Yes.
3, 5, 6, 2, 3, 4, 5, 6. And then 20 is going to break down to be 2 twos and a 5. And then I've got r cubed times r to the 4th. So that's going to be r to the 7th. And this is all the 4th root. So I'm looking for sets of 4. So 1, 2, 3, 4. So that's 1. 1, 2, 3, 4. So that's another one that can come out. And what do I have left? A 3 and a 5. So that's going to stay in. And 4 goes into 7 one time with 3 left over. So I've got 2 times 2, which is 4 times r. So that's going to be 4r. And that's a little 4 there. I forgot to put him there. And then 15r cubed as my final answer.
Okay.
All right. Was that it?
Yeah.
Yeah.
Okay. Well, you're doing good then. Thanks for coming to Math Lab.
Thank you.
No problem. Have a blessed afternoon.
You too.
What's up, Miss Parks?
Hey, Braden, how are you?
I'm good. How are you?
34. I'm doing good. I'm doing good. I had a few people from our class ask some specific questions that I was going to cover. 13, 25, 29, and 39. So do you have some other ones other than that?
Number 11. I was just wondering, do you think there's any way we could possibly do just go number by number on the homework until I understand it?
Yeah, I could definitely do that. Yeah, no, it's Braden. My daughter was asking who was here with me.
What's up, Momo?
No, it's not. That one's not Momo. This one's Brooke. It's Momo's older sister, Brooke.
I got you.
Yeah, there's a few Sparks girls. She said, "What's up, though?"
Not much.
He's loving math. He loves math. Braden loves math. Favorite subject.
100%.
She said her too. Okay. You wanted to start with 11, right?
Yes, ma'am.
All right. I'm pulling up my book on my other computer so that you're not having to read it to me the whole time.
All right.
I had it pulled up, and then because I'm such a technically savvy person, I closed it. I love it when I do things like that to myself. Makes me proud.
It's always the best.
It is. Okay. Oh, number 11. That looks really good. That's pretty.
I mean, I was enjoying it when I looked at it.
I can see why. Okay, so in the numerator, we have 120. Yep. It's actually much prettier than what you think, though. Wait till you see it. Oh, yeah, it's gorgeous. You're going to love it. It's so much fun, and you're going to be like, wow, that wasn't so hard. What happened? It looks ugly, It looks ugly, but it's not bad at all. It's quite user-friendly.
Okay.
It's actually, believe it or not, once you get to the bottom of this, you're going to realize it's really one of the easiest ones on the homework. It just looks ugly. Because when you start getting all those numbers all over the place, it's wonky.
That's what I'm talking about. It's difficult.
Okay, so we have the same bases at the numerator because what we want to do is just break this down little by little when you have a problem that looks this daunting. So we're just going to start in the numerator. We have like bases, so you combine, with like bases, you can combine the exponents. So when we combine a negative 2/5, it'd be 120 to the 0 power.
Okay.
All over 7 to the negative 3/4. And anything, literally anything in this whole wide world raised to the 0 power is 1. So then we have 1 over 7 raised to the negative 3/4 power. And when there's a negative in the denominator, it flips to the numerator. So now you have 7 raised to this 3/4, and you're done.
Okay, so basically anything. Oh, that makes sense. Okay, because I saw the answer in the back of the book, and I was confused. I was like, how did they get the 7 3/4? But I didn't take away the 120 with the 0. So that makes a lot more sense now.
Okay, cool. That's why you just have to remember all of these, and that's going to be as we're walking through this. I've really been praying really hard about this. I worked on this last night. I really prayed about it because each problem you have to approach systematically, but each one kind of brings its own differences and its own nuances that you have to just take all of the properties of exponents into consideration. And you have to approach it like each one kind of has to be approached differently. Like each one has its own unique situation, even though they're really under the same headings. They each one do kind of bring something unique to the table. So, all right.
That's why it's so difficult.
I'm sorry, love?
And that's why it's so difficult.
Yeah, kind of, sort of. Yeah, kind of.
Miss Sparks,
yes.
Thank you.
I'm getting ready to do 13. I'm getting ready to do 13, 25, 29, and 39 for sure on Math Lab because students had emailed me about those. And then Braden was asking me for a few more. Did you have a specific one?
I specifically 13, and then I think that's it for now. And then number 22. Oh, wait, we don't have to do number 22.
Okay, yeah. I have down 11, 13, 25, 29, and 39 to handle for sure.
Okay, and then can we do number 21 also?
Absolutely, because Braden's asked if we could just walk through this together. He would really appreciate it because he just feels like just maybe talking and maybe asking questions and processing it out, it'll help click. And I don't know if you got in here in time to hear me say on these, I really was praying last night for you guys because the different exponents and stuff, you really do almost have to look at each one and figure out which of the exponent rules apply to each situation, like which one applies to this situation the best. To make it the most effective and efficient way to handle the problem. And that's why I was really praying through these. And what's interesting, I've already done tomorrow's classwork too. To me, tomorrow's classwork was easier than today's, even though we're doing all of them tomorrow. To me, it was easier. I don't know. Y'all may not think so, but I did. I thought some of the ones that they asked today were extremely challenging, and you had to take it a little deeper. And I actually watched a few videos on it to see, because I like to see how other teachers teach this. And I found one on Khan Academy. There's one specific piece, and I don't think number 13 has it in there. So, but let me see. I have it starred. Let me see which one I have starred on my paper. Number 17 is the first place that no, actually it happened in number 7 too. that it kind of brought its own unique situation. 13. Okay. But 13 is 16 raised to the 5/9 times 5 raised to the 7/9, then all raised to the -3rd power. And for me, the way I would approach this one is I would go ahead and distribute. We don't have like bases, so the easiest thing to do is to then distribute that -3 power to both things inside the parentheses. So to do that, I'm going to do a little side work here just so that y'all can see this. I'm multiplying 5/9 times a -3 over 1. So that becomes -5. So I've got 16 raised to the negative, 5/3 actually. Sorry about that. And then times, and then my other side work, 7/9 times -3 over 1. So then I've got 5 raised to the -7 over 3. Did y'all get that part?
Yeah.
I'm writing it down. Hold on.
All right. So now, just like in our other one on number 11, where we had a negative exponent and it raised to the top, there's negative exponents, so they'll go to the denominator, and that gives rid of the negative. So now I've got 16 the 5/3 times 5 to the 7/3. Okay, now we're going to go kind of slow here. Remember that a rational exponent gives us a radical. So technically, if I were to write 16 under a radicand, it would actually look like this. Okay?
Okay.
All right. And we cannot have radicals in the denominator. So you cannot have rational exponents in the denominator. All right?
You forgot to.
Yes.
Wait,
Yes, Lev?
you put all the negative exponents.
Where did I put them?
So you had to put them in there. Okay, I see what you did. Never mind.
Yeah, okay. All right. Good question. Stop me whenever you have a question. All right. All right.
Mhm.
So that's why we have to make these fractions or rational exponents. We have to make them whole numbers. So what you want to do to make them whole numbers is you want to take this 5/3 and you want to think in your mind, what is going to make 5/3? What number can I add to 5/3 to take it to make it to the next whole integer?
So it'd be 1/3.
Yeah. Yes. Good job. So I'm going to multiply 16. I'm going to multiply. This is not supposed to be an equal. That was supposed to be a times. I'm going to multiply 16 over 1/3. Whatever I do to the bottom, I have to do to the top because I don't want to change the value of my fraction. So I'm going to multiply 16 times 1/3 on the bottom. And now what do I need to do to the 5 to take it to its next whole number? So what would I add to 7/3 to bring it to the next whole integer?
2/3.
2/3. So whatever I do to the bottom, I then have to do to the top. Okay?
Mm-hmm.
All right. So just so that we can see what this looks like, we've got 16 raised to the 1/3. We put her outside. And then 5 times 2/3 on the top. And then what we're doing is adding across the bottom. So 5/3 plus 1/3 is 16 raised to the 6/3. I'm just doing this step to make sure that you see what happened, even though, Rachel, you knew exactly what you were doing here.
How did you get that denominator, though? The 16 to the 6/3? Oh, do you just keep the 16? You don't, like, do anything to them?
No.
Okay.
You just keep the base the same. We're only adding the exponents.
Okay.
Okay. So now I've got 16 to the 6/3, and I've got 5 to the 9/3. And then at the top, I've got the 16 to the 1/3 times 5 to the 2/3. And then at the bottom, I've got 16 raised to 2, and I've got 5 raised to 3. Okay. Are y'all with me so far?
Not really.
Oh, you're not?
No, it's all good though.
Okay. Where did I lose you?
Okay, by teaching the math. The math is just so confusing.
Okay. Let's see. Okay. At 16 times 16 squared is 256. And 5 cubed is 125. Hang on just one second. And then up here at the top, what I want to do is I want to make my exponents the same if at all possible. And there is a possibility of doing that if I change it to 1/3. And how can I do that? Anybody know?
Change what to 1/3?
I want to change both of the exponents to 1/3, but I can't change the value. What could I do?
No idea, Miss Sparks.
Okay, I could square my 5 and then raise that to 1/3. Is that the equivalent of 5 raised to the 2/3?
I mean, yeah, I guess because you said it was, so.
How on earth?
Well, what do you do when a power is raised to a power? What do you do?
Multiply it?
Yes. So what happens when I multiply 2 times 1/3?
Maybe 2/3?
Yes. So so now what I have is 16 times 25 all raised to the 1/3. So now I've got numbers that I can actually kind of start working with.
How come you're allowed to square that though?
I'm sorry?
How are you allowed to square that?
Because we figured out that 2 times 1/3 is the same as 5 to 2/3, right?
Oh, okay.
These two are the same exact thing, but what I'm trying to do is get it to where I have the same exponent. Because once I have the same exponent, I can multiply my bases.
Okay.
Okay?
Can you multiply the 16 and 25?
Yes, now I can. Because I got my bases to be the same, I can, in fact, do that. So now I've got 400 raised to the 1/3
all over
32,000. Okay.
Oh, that's beautiful right there.
This is
beautiful work.
3 to the 400 over 32,000. So I've got to factor that 400. Your favorite thing.
Oh, Miss Parks, that's the F word.
I know, factor and fractions, your two favorite things.
Oh, I totally love it.
Yeah, I know. 400. But I'm going to do the factor tree like y'all like. So I've got 2 times 2 times 2 times 2. Did I get them all? 1, 2, 3, 4. Yep. Times 5 times 5. All over 32,000. So I'm looking at sets of 3. So what can I take out? This, and this. So I've got one set. That's 2. And then everything else has to stay inside. So that's 2 times 5 times 5, which is 50. Thought it was going to be a little bigger than that. All over 32,000. And now I can take that down. And that's my final answer.
That is so hard.
Yeah, that one is probably, in my opinion, one of the most challenging on the homework. There are a couple others that I felt like were kind of up there with it, but I thought to be number 13 on the homework, they went 0 to 90 in like 3 seconds flat. I really would have to say that. But what it does do, for better or worse, I really honestly don't think there's only one exponential property that I think we don't use in this one.
Okay.
But that one definitely is, because you literally are taking every single step trying to figure out what are the properties of exponents that I can use to continually simplify this problem. This is definitely worthy of study, because if you can figure this one out, like if you separate yourself from this and you work this several times until you've mastered this particular one, I feel like, in all honesty, you will, this is just a good exercise of really understanding them all. But it was definitely hard, Rachel. I'm not gonna. But this exercises all those properties of exponents, which are really, really critical. And these are good for calculus and pre-calc, and they're really, really important. So, was there a part, Rachel, something you and I have kind of discussed before, is like, as we're walking through it and processing through it, it seems to make sense, but sometimes, like, it, when you sit down to work a problem, it's almost like, getting a writer's blank when you look at a blank page and you have to write an essay. Is that part of this one for you? What happens on this one? Just all the different steps, or what?
This whole lesson, I don't get it.
All right. Well, let's process through the next one together a little bit more.
Hey, Miss Mark.
Yes, love.
I'm gonna get off now. Thank you for helping me.
You're leaving because of this one?
Yes, I'm leaving you, Miss Sparks. I'm sorry.
You hated it so bad that you decided to leave.
I have to, Miss Sparks. I'm sorry.
All right.
Thank you.
Well, we'll be doing so you can go back and watch the recorded.
Okay. Thank you.
I know I'm going to do a few more.
Alrighty. Appreciate it.
All right, Rachel. No problem. Have a good afternoon. Rachel, is there another one that you would like me to do in this section, or
I did all of them in class with you yesterday. I just feel like there's so many steps, and I am prone to making mistakes in math. So I feel like I don't know. It's just so much. It's overwhelming.
Yeah, I will definitely say I'm not I don't do a lot of math in my head. I definitely like to write steps out. And I was actually able to do some of the quiz work in my head, and it's these types of problems. So there wasn't anything, I haven't worked them all out on the quiz, but I've worked a few out. And because I wanted to make sure, I wanted to eliminate, if anything was like number 13 on the quiz, I wasn't going to put it on there. I like to have numbers like 13 in a homework, because I feel like it's important to challenge ourselves to rise to the occasion.
Right.
But I do kind of wish that didn't need to be a number 13. That needs to be like a number 24, something kind of on down the road a little bit. But because it was hard for sure. But is there another one that you would like for me to do and walk through with you? Because I'm going to definitely do 25. But if there's one before 25,
Yeah, can
let
you
me know.
go ahead and do number 17?
17, yes.
17 and 19, because
17 and 19.
please.
17. Okay, that's the fourth root 8 times the fourth root of 8 equals the fourth root of 64.
That's all
Which, yes, which then I would go ahead and factor 2 times 2 times, and I just happen to know how many twos. Scary. 4, 5, 6, 7. I think that's it. I said I knew. Wait a minute. 2 times 2 is 4. 4 times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. So I said I knew. All right. So then, thank you very much.
I don't know what to do with it.
So then I'm going to cross out 4. And that leaves me 2 to the fourth root of 4. This is one of the ones that I starred because I was hoping that I would be able to explain this. And actually, this works out better. This is kind of like what we had just a few minutes ago when you asked me, how do you know to square it? Remember on number 13? Like this actually, if you have, this is actually times 4 to the 1/4.
Right, I get that.
Okay. Which can then be written like 2 squared if I'm not mistaken. Hang on just a second. Hang on just a minute. Because you're supposed to, I'm trying to think in reverse because this right here can then be further broken down to be 2 the square root of 2. So the fourth root of 4 is the same as the square root of 2.
So how would I know to do that though?
Whenever, because I was trying to think, whenever there was one other place on number 25, you actually get down to 2, and maybe I'll just cover it then. But you want to get it to the smallest root that you possibly can. That's the simplification process.
Okay.
I'm going to tell you, if you got it to here, I wouldn't count it wrong because that's a feat in and of itself. But this is actually it in its simplest form. So that could possibly show up on an ACT or an SAT. So I feel like you really need to understand that. Like to know that this is the equivalent of this.
Okay, so if I was going to do number 19, then would I just do that same thing but in division? So I'd do 64 divided by 2, which would equal 32 and then
Because they're both fifth roots. Yeah.
so then it would be, I want to show you, but I don't know how. It'd be like square root 32 with a 5 before the square root thing.
Hang on, let me switch over into the. Oh, okay. All right, you tell me. Okay. I think what I did on that one is do this.
Oh, and then it would be 32 to the 1 divided by, so it'd equal 2.
Yeah.
Okay. But what if it didn't equal a precise thing? Then what would I do? Like if it was 32 to like the 6th thing. 32.
Okay. You would just leave it in its radical form.
I wouldn't like pull anything out like we just did for number 7.
You pull everything out that you can, and then whatever's left, you leave it in. So let's just say, let's say there was an x to the 4th up there at the top. Then it would look like this.
Okay.
So if you can't pull anything out, it just stays in. You pull out what you can.
Okay.
Does that make sense?
I think so.
And everything else stays in.
Okay. So then for like number 21, I would multiply those two together and divide them. 36 times 1 divided by 4.
Yes.
Okay.
Do you want to see that?
Sure. Well, let me solve it. So 36 times 9 was 324. Divided by 4 is 81. So it would be 81 with a little 4 thing outside of it. So it would equal 3.
Yes.
Okay. About that.
That's why I said once you start whipping through the rest of them and you look back at number 13, it's really hard.
Yeah.
You know what I'm saying? Because some of them were just like after I did 13, I was like, wow, this is going to be daunting for them. I was like, I sat up and did everything last night plus everything for Wednesday because I have this thing. I really don't want, I mean, sometimes y'all will have to work an hour and a half to 2 hours to make yourself understand something, but I don't want anybody to work 3 and 4 hours in math. So I wanted to see how long it took me to do it all. Yeah. And I was like, oh my gosh, because if they're all like 13, I was thinking y'all would spend hours, but I was able to do like 15 through, I don't know, 30 something in probably 15, 20 minutes.
Okay.
So obviously I know how to do it a little bit better, but I'm thinking that it wouldn't be, you know what I mean?
Yeah. So, and then I remember 23 on the board yesterday, but
well, I can do it again.
Okay. Because that one looks also really confusing.
It's ugly, isn't it? Some of them start out ugly and then just turn out a little prettier.
Okay.
They're not too bad. Times. And then I think that the between fractions and factoring, you put both of those things in the same lesson and people are already shut down.
Yeah.
You know, 2 of y'all's least favorite things. So you can go ahead and multiply your 3 and your -6. So that's going to give you -18. So that's no big deal. Now, for the inside, we're going to have the 4th root, and then you've got 32 and 5. But what you want to do is you want to break down your 32.
Are
so
you
that's going to be 2.
Together?
I'm sorry?
Are you allowed to multiply together?
Yes, you are allowed to multiply what is under the radicand together. You cannot add them unless they're similar, but you can multiply them. Great question, too.
Okay.
8, 16, 32. So now I got to pull out sets of 4. So there's only 1, 2 that can be pulled out. So that's going to be -36. And then what is left is 10.
Where'd you get the -36 from?
I multiplied this 2 because I pulled out 1, 2 from under the radicand, and it's multiplied to that because it's 3 times -6 which gave me negative 18. And then 2 times negative 18 is 36.
Okay.
Because you've got anything that can come out. Like, remember how we talked about we pull perfect squares out? You know? So this, now we're looking for a set of 4 because it's a 4th root.
Okay.
So you pull things out in sets. But I do understand where you're coming from, and I'm known to do those simple mistakes too. And when I talk and write at the same time, it's worse for me. So I think when you're working these problems, just take your time.
Okay.
The quiz that's set up for Friday, there's only like 14 problems, and some of them are really, really quick. Like, what was the one that we just did a second ago that was not too bad that we were talking about? I was like 15 or 17 or something like that, that weren't too bad. A lot of them are like that.
Oh, good.
Okay, so we did 21, 23. I'm sorry?
That was the final answer.
Yes, I'm sorry. It was. And that's C, I think. Negative 36 times root 4, 10 root 4. That's what I wrote. Okay. All right, so number 25 is what, the 6th root of 256?
So would you do a factor tree for that one?
I definitely would do a factor tree.
Okay.
So 128.
I'm sorry, I was watching the screen. I was on my phone. So I didn't see you doing it.
Oh, no, you're fine. You're fine. One, two, three, four, five, 6, 7, 8. So that's 8 2s. So I can pull out 1, 2, 3, 4, 5, 6. One set of 6. So that's going to be 2 on the outside. And that leaves me 2 on the inside.
It leaves you 2 on the inside or 4 on the inside?
Well, it leaves me a 4 on the inside. I'm sorry. But here's one of those things. Remember when we were talking about earlier? I said number 25, you're going to do this too. This would be 4 written to the 1/6 power, which is the same as, believe it or not, this is 2 times root. So 2 to the 1/3 is the same as 4 to the 1/6.
How would I know that it's 4 to the 1/6? How would I know that?
When, I don't know, I'm trying to think. Typically when it's even, like a 6, a 4, something like that in your root, and you have something that has a square root in it, like a 4, a 16, something like that, you know that it can be written smaller.
Okay, so how do you get from 2 times 4 to the 1/6 to 2 to the square root 2 with a little 3? How do you get from like I don't know how to describe it to you because I can't like point, but 2 times 4 to the 1/6, and then the problem under that. How do you get
that? Hang on, let me. This is what I was praying about last night, was being able to communicate this well. So. hopefully this will do it. And it's just fractions. And this is the same as 2 squared. We did this earlier.
How is that the same as 2 squared?
4, how is 4 the same as 2 squared?
Yeah. Oh, okay.
And then 2 times 1/6 is 2/6, which is 1/3. And that's how you get to there.
But what happens to the 4?
It's this 2 squared.
Okay. So I have 2 squared to the 1/6. And then, yeah, but whenever I have 2 squared to the 1/6, then what do I do?
Well, then I would have 2 to the 2/6, right?
Okay.
Which equals 2 to the 1/3, which is that.
Oh my gosh. Okay.
All right. So let's maybe if I do it more systematically. So I've got 2. This is where we started. Okay.
Mm-hmm.
Run out of room. 2 times 2/6 equals 2 times 2 to the 1/3, which equals 2. Because it falls under the simplest form instruction, that's why they want you to go all the way to here, because that can't be reduced anymore. But because you can kind of pull a square out, they want you to be able to do that. But could you easily get to this?
Yeah, I can do that.
Okay. Well, we'll continue working on this other. I don't think there's any of those on the quiz. I didn't see them. But remember way back on number 13, if you still have it in front of you.
I do.
Where it's kind of there's a similar process going on where in the in the numerator where we had 16 raised to the 1/3 times 5 raised to the 2/3, where we kind of broke out that 5 squared in order to get our exponents to match.
Yeah, I remember that.
So what we're doing is manipulating the exponent rules to, first of all, get us to simplify and solve these problems. And then secondly, like on this one, which is number 25, I think, secondly, to get it to its simplest form. And this cannot be reduced any further. This is simple and it's been solved. This one here has, but it's not technically in its simplest form. But I would be totally happy if y'all got to here. But I would be failing you if I didn't try to help you understand how you could get there, because I could totally see SAT questions like listing things like having an exponential expression like this and saying mark all that or find the one that is equivalent. And you could have something like 6 to the 4th. And one of the answers perhaps might be or the sixth root of 4. One of the answers might be the 3rd root of 2. So I feel like it's important that you guys know that. You know what I'm saying?
Yeah, I get that.
Have you taken the SAT, ACT yet?
I have. No, I did it when I was in 11th grade, so.
Okay. That to me, I feel like I have seen that on some of the pre-tests, and that's why I want to make sure that we're at least talking about it.
Okay.
And most frequently, Rachel, when you get down to something like the sixth root of something or the fourth root of something, and there's a square root within it, that's going to be where it's going to occur most frequently in math. Not that it couldn't occur elsewhere, but it's most commonly they're going to want to know if you can denote a square like a 4 or a 16 or a 25 to be able to pull that out. It's not going to be some kind of weird number, like obscure. I don't know if that helps, but there is, let's see, let me see how many more. It occurred again. Like I know I have 17 starred. I have 25 starred. And there was one other place that, number 7, it actually happened. It there as well. Because it ends at 25 to the 1/4.
Which one?
And they have it as 5 to the 1/2.
Oh.
Let me see if it happened. I don't have any other starred, I don't think. For that particular exponent rule, that I was starring them for that because I feel like those were ones where you really have to be searching for those patterns in math. I think you have to kind of do that with this whole exercise, looking for patterns and things like that. But those in particular, you needed to. So I was going to move on to 29, unless you have one in the middle that you would like for me to do.
I think I understand number 27, so that's fine. You can move on to 29.
Okay, so 29 is 3 over the 4th root of 144. So what I want to do is simplify as much as I possibly can at first. So I'm going to do a factor tree. So I've got 1, 2, 3, 4. So I can pull a 2 out. And then I'm going to have the 4th root of 9. So then this is kind of interesting because this is kind of one of those where I guess that rule would kind of come into play also, because I'm thinking in my head, this is another pattern that I just saw because I'm looking at my work and I'm like, I don't know how I'm going to, if I actually multiply both sides of this, how many 3s do I have in 9?
2.
So then I only need 2 more to get it out, right?
Right.
So if I do the 4th root of 9 times the 4th root of 9, top and bottom, got 2 times 4th root of 9, that's 3. And so now this actually cancels. So I've got the 4th root of 9 over 2. Now, do you see a square root within 9?
Well, there's 3.
So just to kind of show, this is going to be 9 raised to the 1/4 which is equal to 3 squared raised to the 1/4.
Is that it?
Did I do that right? No. It's great. 3 squared. Did I write that right? Because your end result is √3/2. Because you can pull a square root out.
How do you get √3/2?
It's that same principle that we had before.
So from 3 squared to the 1/4, how do I get √3/2 though?
I'm trying to see if I wrote it right. That's what I'm trying to. I feel like I wrote it wrong, and I wrote it right earlier, and I didn't make my notes because I just did it in my head over here. I'm sorry.
You're fine.
So squared. That's it. Three squared. There it is. 3 squared to the 1/4. Is the same as, I was like, I don't know why, say, so 9 to the 1/4 is the same as 3 squared to the 1/4, which technically is the same thing as this would then be 3 to the 2/4, correct?
Mm-hmm.
Which really is the same as 3 to the 1/2, which is really the same as that. I don't know why it took me a minute to get there, but that is how that happens. And remember when I was saying earlier before the long silence, and it took Miss Sparks a minute, but remember how I was saying earlier when you have like a fourth root, and then earlier in the other problem we had the sixth root?
Yeah.
When they're even roots like that, that's when you're going to find to be able to pull those squares out. Like, I know it's one of those things for me now. I just look at it and I know it's going to happen. But for me to process back, like how I get there is the part that I struggle. Like, unfortunately, I can look at the fourth root of 9, or I can look at the fourth root of 4 and know that that's the same as the square root of 2, or this is the same as the square root of 3. It's one of those things. So me trying to figure out this part so that I can make sure you understand was the part that I struggle with. And I apologize for that, because I look at it now and know, but it's because I've been doing it for so long. So undoing it takes me a minute. But that is the part of simplification, where 9 to the 1/4, I see that there's a square root within that. So I want to break it down. And so you take it from this step to here, and then you multiply the 2 times the 1/4, which gives me 2/4, which is the same as 3 to 1/2, which is root 3. And that's how you know it's in simplest form. And I feel like that's why it's interesting to me that the questions that came up most frequently on this homework were the ones that had this process, because I feel like everybody's looking in the back of the book. They ended here, root 4/9/2, and wondered why the back of the book had that.
Yeah.
So I'm sorry for the long pause, but like I said, I was like, why can I not go backward? Does that make sense though? It's one of those things. I feel like it might make sense to you once you see what it does, but maybe not recognizing that you would have to do it.
Yeah, I never know when to do it.
Okay. Well, all right, let's look at all of the occasions that it's kind of happened. One of the occasions, let's just look at those by themselves without doing the problems, and maybe it will be more recognizable. So we have root 4. Is there a square root under there?
Yeah, there's 2.
So we got 2 squared, right?
Mm-hmm.
Raised to the 1/4 power, which equals 2 to the 2/4, which equals 2 to the 1/2, which is root 2.
Okay.
That's the one case that it happened. Okay.
Okay.
Now let's look at another one. Little different. But just recognizing that it's going to be an even root, more than likely. So the other place that it happened, this was here. It was a sixth root of 4. And there's a square root underneath there. But you're going to half that. So this is going to be 4 to the 1/6, which is 2 squared to the 1/6, which is 2 raised to the 2/6, which is 2 to the 1/3, which is written like that. So it's half of that with the square root of 4.
Okay.
I'm trying to show you all the scenarios that it actually happened in the homework. So hopefully the pattern itself will be a little more recognizable to you.
Yeah, now that you're like spelling it out, I kind of understand it a little bit more.
Okay. Because like I say, now I recognize them, like I think what 29 was one as well, correct? Yeah. That was the other one that we had. So hopefully that helps, because now I basically, I would know this fourth root of 9 is the same as the square root of 3. So half of the 4 and the square root of 3.
So that's what you do, is you just half the outside thing and then do the square root of the inside thing?
That is the quickest way to do it, but the logic behind it is this. And that's why I kind of have that pattern of doing it quickly like that, but this is the logic behind it. This is where the math part of it comes in.
Okay. So then I think I messed up though, because I got square root of 3 without
Over 2, right?
Well, what do you mean?
For number 29, right?
Yeah, what you're doing, I got all that, and I got to the 3 to the 1/2. So that would be the square root of 3. But then what happened to the little 2?
Didn't we bring it over?
I don't know, like what how you usually did it.
Okay. Maybe I just need to do it again.
No, okay, so when you have 4 and then
Okay, where we ended when we got into that was root 4 over 9 over 2,
yeah.
right?
Mhm.
Which then would give us root 3 over 2.
Oh, okay. So
That's the final answer.
okay, so you don't have never mind. I was confused.
Okay. All right. Okay. Is there one between 29 and 39 that you would like for me to do?
Whatever the hardest one is simplifying the expression.
The hardest one is what?
Whatever you think is the most complicated one.
Okay, between there. Let me see. There is a lot of factoring that goes on in number 37. I don't know if looking at the ones, I don't know how you feel about them, but a lot of people, the fractions for like number 33 and number 35, because they're fractions attached to radicals, they can be intimidating. But really, in all honesty, all you're doing is you're acting like that. Those are, variables, if you will.
Mm-hmm.
Like
number 37.
37.
Yes.
Yeah, I was going to say that was probably the most difficult because of all the factoring that you need to do. So, because to me, 33 and 35 were fine. You just really needed to add the fractions. And I think they actually had the same denominator, so not a big deal. So you got -6 times the 7th root of 2 plus 2 times the 7th root of 256. So obviously I'm going to have to factor that 256. And I'm just going to use my work that I have over here. 1, 2, 3, 4, 5, 6, 7, 8. I think I have 8 twos. That makes up 256. So this becomes, I can pull that 2 out because it's a group of 7. So 2 times 2 is 4. And now I have the 7th root of 2. I made a big old long radican for that for no reason. And now all I have to do is combine my -6 and my 4 for -2 7th root of 2. And that's my final answer.
Okay, that makes sense.
Okay, cool. And let's see. I have 39 down as one of the questions that was emailed to me.
Okay. So would you start by factoring the 1250?
Yes, ma'am.
Okay.
And since I had already factored it earlier, I'm going to go ahead and use my factors from earlier unless you'd like to see me factor it.
That's fine. I just factored it anyway, so it doesn't matter.
Okay. One, 2, 3, 4. So I'm going to pull things out in sets of 4. So that's a 5. I can pull this 5 and it gets multiplied to the 2. So that makes that 10. And then root 4 of 2 minus, and then, I can pull 4 2s out here. So that's going to be 16. No. Pull the 2 out. And that makes that 8 a 16. 4th root of 2. So 10 minus 16 is -6, 4th root of 2. And that's my final answer.
Okay. I think I understand everything now. Thank you.
Oh, no problem. Thanks for being patient with me as I was working through the other. And then, like I say, as I look back over this whole lesson, I honestly feel like number 13 was the most difficult problem on the homework. And tomorrow's classwork is a lot easier. And nothing like 13 will be on a quiz.
Oh, good. Okay.
But I do feel like it was a good one to kind of exercise all of the rational exponent rules. Because we certainly did. If you don't have any other questions, you have a blessed afternoon.
Thank you. You too.
Bye-bye.
Bye. How do I turn it off?